hear me because I'm got the mask on and everything. But so we have an induction furnace here, and the way the induction furnace works is it takes 480 volt three-phase and turns it into, our furnace is 3,000 hertz. So full, when it's running at 3,000. It's like alternating current at 3,000 hertz. Normally it's 60 cycles, right? So it's a high frequency induction furnace. They actually make different furnaces. Some of them are medium frequency, like 400, 500 hertz. And then there's low frequency, actually line frequency, down to 60 hertz. The deal is, the higher the frequency, it has to kind of be matched to what you're melting. And there's a whole bunch of physics involved in that, I'm telling you now, that I don't even quite understand. But the deal is that what's going on there, there's big capacitors in here, and I'll show you in a minute. There's big capacitors in here, and they actually tune the furnace to the metal that's in it. It's got to be like, it's kind of like almost like a resonance frequency kind of thing. And what you're doing is, it's kind of like a microwave for metal. You've got the crucible in here. Okay, so hopefully everything works. We should lubricate that. Okay, so inside of here, there's a coil, and that coil is surrounded by fiberglass. On the outside of that is some refractory, some like ceramic, and then the outside of that is some more ceramic. So there's actually a couple layers of ceramic on there that keep, actually that's that case there. We have actually about 1.5 inches of like the main refractory, and then we have a backup refractory, and then we have fiberglass in the coil. So the deal is that up against the metal, it's metal temperature, right? But like 1.5 inches or 2 inches away, it's water temperature. Okay, so you got water cooling going in there. So these hoses are not only cooling water, they're also the conductors. So inside the middle of that rubber hose is a big braided copper cord that feeds the furnace. For these furnaces, you see this one only has two. There's one going in and one coming out. So it's got one coil. This one in here, it's broken into upper and lower. Okay? And the way those coils are in there, it actually stirs the metal. So it's good and bad. Stirring can also bring the metal up in contact with the surface. So if there's stuff in the air that's bad, or if it's oxidizing, that's bad, right? But the good thing about it is if you put like some alloying elements in there, they will dissolve and get mixed in really well. Okay, so induction is one of the ways to heat. We will go through some of the other types of furnaces. We do a little bit more of that in the second casting class with when we start using the tilt core furnace. This is called a lift coil furnace because we're lifting the coil off of the furnace and the crucible stays there. We have some that actually they push the crucible up and out. The problem is you're now exposing the cylinder to the heat from the radiant. Actually, this does not get that hot. It just gets hot because the metal gets hot, and the crucible gets hot, and then it gets this hot. So it's a magnetic field going through, you know, as far as I'm concerned, magic. It's like, you know, it's resonating. Okay, so what's actually happening? Think about a transformer. If you took your intro to electronics class, a transformer has a coil, right? With 60 hertz. Remember, a transformer doesn't really work if you have DC, right? Because you need to have that movement in order to change the flux going on. Okay, so you have a coil and a coil inside, and the number of turns on that coil will determine if you're going higher voltage and lower current, or lower volt, you know, whatever. I'll say that. Okay, so here though, we only have one coil. So you're inducing a current in the metal that's in there. So when you see this metal melting, what you see is arcing between chunks of the aluminum or whatever's in there. So what's happening, it creates an eddy current, which kind of like, it's randomly electrons kind of moving around, right? So it's currents, but they're being kind of forced in random directions to some extent. And eventually, that heats the metal up, right? Because when you have conduction, it creates heat, especially there's a lot of current. It gets hotter, which increases the resistance. It gets hotter, increases the resistance. Eventually, it melts, okay? So, if you've ever looked in this furnace, when you have molten metal in there, it actually mounds up the metal a little bit, okay? So, it's like a little bubble. I melt now, but we are out of aluminum. We have to get some aluminum now. We have some scrap laying around, but we'll get some aluminum from Olsen Aluminum probably. And so we have molten metal in here, and typically it's going to be kind of mounted up. Depending on the frequency, the lower the frequency, the more it kind of like wants to move that metal around and stir it. So low frequency furnaces, when you get molten metal, sometimes there's erosion because of that big stirring effect that goes on there. Okay, that's kind of how it works. So what we do is, we first have to get cooling water on there. If you ever don't have cooling water on here, it is a really bad deal. The cool thing about this one though is, if I have a failure in the cooling circuit, I just lift the furnace up, and I can stick my hand in there like a few seconds after I lift it off the back. This thing's hot, I take it away from here, and we're all good. That one there, the refractory in there is stuck in there. It's just this one tilts to empty the metal out, right? So that takes 8 hours to cool down. So there's a cooling circuit on this that we push on the pump. This is the pump panel here. There's a cooling circuit on there that will cool it for 8 hours and then shut off. Because I don't want to, if you pour it on a Friday, I don't want you to come back here on this, Saturday night or whatever to turn it off. Okay, so there are 3 furnaces. And by the way, this is a brand new furnace. It's only been used once. Okay, brand new to us. It actually came from one of my former students that bought this exactly same furnace for high school. So Port Washington High School has this furnace at 70 kilowatts. We have a 100 kilowatt unit, so a little bit bigger. And they're melting aluminum, so it's former students went through this class, and now he's teaching tech ed there, okay? When he bought the furnace from the I think it was Illinois somewhere, they had this other furnace, and they never used it. So a little bit of horse trading, and we have this furnace now. And then last semester, it cost about $5,000 to get it hooked up. We put a new switch in here. So we always had four bays, but now we have 4 switches actually. You could actually put one more furnace on there. It came with 2 switches. And we're just storing one of the switches right there. So here's the deal. We're going to start doing the procedure now. Okay? So the first thing we're going to do is turn on the water. So let's you guys kind of stand a little bit, come around here, stand far apart. Okay, so you turn on the power. Now there used to be lights. When you push the buttons, they would come on, but they've been used so long that the lights have burned out. One of these days we'll order some new ones. Pump start. So this green button right here, pump start. Unfortunately now it's a lot harder to hear me because the pump's on. Okay, and then what we're going to look at is a couple of things. Okay, there is a thermocouple right here. It takes the temperature of the outgoing water. Okay, so if you look carefully here, this water cooling outlet, water cooling inlet. We cool this actual electronic unit, and then it goes out to the furnaces, and then back to this. So it's this big loop. Outside is basically a car-sized radiator that has fans on it. And those fans will keep this at a maximum, I think it's 80 degrees. Okay. So, as you're doing stuff in the lab and you're melting, every once in a while you should look over at that thing, and if it's ever over 80 degrees, come get me right away. I think 82 is okay. The fan comes on, it goes back down to 80. The deal is that one day we're doing it, we did some electrical work, and they forgot to hook up, like it looked like it was working over here. The pump was going, but the fans weren't hooked up. So we're running that furnace. Luckily it was like 10 degrees out, and so I had all the students go home and get their box fans from their door, and we put a whole bunch of fans underneath it, and we actually got through the night because we were halfway done melting. When you're halfway done melting, you can't empty it because it's like all melt welded together, but it's not liquid yet, right? So, okay, so I have the pump on. I don't have any power on here yet, right? So next thing I'm going to do is I'm going to make sure the right furnace is connected. Right now, our portable furnace is connected. We don't want that one, okay? We're going to be melting with, okay, the big thing is you never want two of these on at once. You always got to turn all of them off and then the other one on, okay? So watch your fingers, that you can smash them against the edge here when it comes down. Actually, it's on the top. Okay, and then this is the non-ferrous furnace, this is the ferrous one. So this one we melt brass and aluminum. Could you melt steel in here? Yeah, if you had a crucible that could handle it, you could. You have done it, but a plain graphite crucible tends to dissolve relatively quickly when you have steel in it or something. Okay, you can melt cast iron in it. It's possible. Not recommended though. Okay, so I'm going to put the non-ferrous furnace on. That's where you bash your knuckles. Okay, the next thing is, this is the most important thing probably, you need cooling water to the correct furnace. Now it really won't let you turn the furnace, it won't let you run it, but if you get an error code, you know why, because it says valve is open when it's horizontal. This one's open, I'm going to shut that one. Typically, you shut the one you're using, you turn the one on and it's working. Now, okay. So theoretically, we have water flowing into this furnace now. Okay. This should register after it's been running for a while. It should register above about 45 psi. Otherwise, you will not have enough pressure. The furnace won't turn on. It's got this happens in the wintertime. What happens is all the water in the radiator is cold, so it shrinks a little bit. And so there's an expansion tank in there, and if we lost a little bit of liquid, that expansion tank then can't take up that low spot, okay? So it won't turn on. You won't ever get to like 45 psi. So let me know if that's the case. We actually have to inject some water into the system typically to get the expansion tank more filled with water. Okay? So we should be ready to start turning the power on, except we got to get this in a situation where we can turn it on. What I'm going to do is I'm going to put this back down. I see we got a couple chunks of aluminum there. I put them in there. It's like you do not want to run a furnace. It needs to be lubricated. If you run a furnace without anything in it, it's like taking your car out, and just revving it to like 8,000 RPM with no load on it. It's super bad for you. Okay, when you put charge in the furnace, it can't be jammed in there because it's going to expand a lot. You'll break the crucible. So as it's melting, if you just jam a bunch of stuff in there, it will break the crucible every time. So I always put it in there, making sure that there's room on the edge. The other thing that I would do, kind of come up one at a time, is that I'm not going to really turn this on really high. But that crucible's got a bunch of scale on the inside of it. You do not want to start melting the scale on it. And the reason is that scale will heat up immediately. It's like aluminum foil, right? And it kind of like degrades the surface of that crucible because you're superheating one little spot on that crucible surface. So we're not going to turn this on very high. Okay. Also note that this has 356 written on it. Anytime you melt in here, if you're melting 356 when we're done, that's the normal alloy we use, you got to stamp them. If I come in here and there's something that's not stamped, this is probably about, I don't know, 30 bucks worth of aluminum here. If this is not stamped, it's scrap. I don't know what it is, okay? So we have some stamps. We might need to have someone redo them. These are machined and they're kind of all buggered up now. So if someone wants a machining project or something like that, or even a forging project. Okay, so now we've got something for it to work on. I don't know what this is. If it's titanium, ferro-titanium spark. It's pretty cool. Okay, so make sure this is off. This is the power dial or output level dial. That has to be off. Okay. So in here, there's a whole bunch of 9-volt batteries, and it's a normally open circuit. So when I push this button, I energize it and I close the contact, but only temporarily, right? So this is kind of weird. So pay attention. Up, down, up. Remember that clump? Now the main breaker is actually keeping the circuit open or closed as a contact. And now what? Okay, so I'm going to, at this point, if I don't have any errors, this little button right here should be red actually. Okay, that light might actually be burned out. It's usually red. So I think our red, just so you know, if it stops working, like the furnace all of a sudden stops, look up here, there's error codes. Like if you go ahead and turn the water off, the big main breaker. Now that'll give me an 8-hour cool down. So the main breaker, the big, yeah, just got that. It's hard. Okay, now I just got a water pressure error on here. Okay, so it may be that the filter, there's a filter right here, the filter can plug up or something like that. And if the furnace shuts down, this should be a red light right now. So I got to replace this. That's new. Okay, so turn that back on. Turn the pump back on. Okay, and I still have a fault there. Now I cleared the fault by hitting this reset right here. And it is ready to activate here. So I'm going to put the converter is on. And now I'm going to turn up the power. And this is the kilowatt meter. Frequency is like, basically it tries to, it's all solid state, so it's going to control at 3,000 hertz. And the voltage, the coil voltage, you really don't look at that very much. If anything goes into the red, if anything goes into the red, that's a problem, right? Part of the red. Now here's the weird thing. These little things here, if you have a little sack of electricity on it, you can actually move them sometimes. They're really super sensitive. So we actually magnetize one of these things and just see that red one. So they look okay right now. If they go back down to 0, it's fine. Okay, I want maybe just kind of come over here and take a peek in there. If you want to do it individually, what you'll see, you see the lightning going on in there? Okay, what that is, okay, it didn't like that. I was just kind of like, it was very cool, but it didn't like that. So I just reset it, so it should be okay. If it sees something while it's running that it doesn't, it saw like a big fluctuation in its current or something like that. So what was going on there was the eddy current was actually arcing between, I've never seen it like that powerful, that's pretty cool. Probably not good for it though. Smell a little bit of brimstone there. So that's not how you want to melt. What you want to do is just turn it on kind of low just to get the crucible kind of warmed up a little bit, and then kind of give it more power. So what we would do is we would carefully scrape out that little bit of skin on there when we're done pouring, and then just go and get anything else out that before we start pouring. The other thing we'll do is we'll use a little bit of flux, and we'll go into that a little bit more once we get to the melting part of it. So, okay, let's say all of a sudden we lose power on it. So go ahead, turn it on. Okay. What would I do? Well, if I was running that furnace, I got a problem now because I can't, even if I dump the metal out, it's going to take 8 hours to cool it down. This one, I'm going to do is I'm lift it up, right? But I have to talk about the emergency procedure. It's 50% water and 50% glycol. And it's about, I don't know, $500 to redo the whole system. You got to put deionized water in there. So if we put city water through it, it does some bad stuff. Okay, it's like flushing your whole radiator in your car and having to dilute all that crap back out of there and get it all back where it was. Maybe you're not that fussy, but so there is a procedure right here for emergency cooling system. It says close the 2 yellow valves. Okay, look for yellow right up there. So those go out to the radiator, all the water like all the radiator. That way we don't have as much dilution to do at the end to get back up to running, okay? So I'm going to isolate that. So what we're going to do then is you see this is the outlet, that's the inlet. So if I turn city water on here, it's going to go up into the system. And by the way, there's one more yellow valve up at the top that you can, that just saves the water that's in the pump here too, okay? So you turn that valve off, those 2 valves off. Everything yellow up there. So water's going to come up from here into the system, into the cooling circuit, out to the furnace, back in, up and out, and then that's plugged off. You open that valve there into the drain. Okay? So essentially we're putting city water through the cabinet and through the furnace. That's the emergency procedure. So if something happens, you got about, in that furnace, you got about 30 seconds to react. Because you'll start hearing a pounding noise, and that's steam building up in the coils. And eventually, what will happen is you'll melt, the fiberglass will start burning on the outside of the coils, and then the coils themselves can actually fail. Now, the bigger problem is if you have a spill internally. In other words, there's a crack in that furnace, the molten metal will start to fin and go into the refractory in the crack. And then even if you put a plug on the surface of that, there's still molten metal. Every time you heat the furnace up, the induction is heating that's liquid metal in there too, right? Inside the crack. We actually had a failure in Madison, and it was exciting. Let me tell you, we have the hydraulics that are right on the side of the furnace here to tilt it. So I was standing there, and the metal was actually hitting the ceiling. It was going down on top of my head. This before we had like helmets. Okay, that's how I lost all that hair on top of my head. Not really, but it was definitely painful. So the metal was going up and coming back down, and then we dumped it in. This is kind of a funny story. We dumped it into a wheelbarrow that had sand in it, and the idea was before you turn the furnace on, you need a place to put all the metal in the furnace. I won't let you turn the furnace on. We have these ingot molds over here. You see how they're rusty? What would happen if we poured molten metal into them right now? It would be like a mortar round, literally. We've actually had these lights taken out by someone doing that. We poured molten rods into an ingot mold. It took the light out. It went up under his face shield. It went like literally splattered on his 2 glasses. It went in his beard. It went up. It came back down his neck. It came back down his glove. Okay. Now, what he was, kissing the ground about was the fact that I had just made him put his safety glasses on underneath his face shield because it went up under the face shield. And I kid you not, we used to have them on the wall. There was a splash on either one of them right where his eyeballs were. So there's a huge amount of energy. So those will have to get shot glass before we pour any metal into them. Let's just get in the habit of doing that. And in the middle of the winter time, we could probably, look at it and say, yeah, it's probably okay. But the moisture in the water hydration of rust on a thin layer of rust like that is enough. It expands 1,000 times its size. So if it's a droplet of water, it's 1,000 times. It's like this big then, right? So and it goes from there to there in like a millionth of a second or something. Okay, so before we turn the furnace on, we have a place to put all that metal, and then we melt. We do whatever we're going to pour, and then we take it off. Okay. What else is there? tell you about it. So safety-wise, you know how the emergency procedure goes. On this one, we would just lift the coil, and it probably will keep an eye on the water. I'm going to try not to have to put the city water over it because it's going to be like 15 hours of goofing around after that. Okay. We're going to pour this just like we normally do with that shank that's right behind you there. You can sometimes pour in hand ladles when we do the terminal bowl unit. We do pour in hand ladles. Okay, shutdown procedure. So we've been running it. That furnace is on. Turn that on. This we have a right. Yeah, just pull everything. There you go. Okay, so now we're running the furnace. Didn't want to go out because the water wasn't up to pressure yet. There's a pressure sensor right here that determines if you got enough water to turn it on. If it goes off, it could be because of the low water pressure. Okay, so now we're running. I'm really not putting any power on it. Okay, so we're done. We lifted that up and poured it. We're all in there. Okay, all we got to do now, that base cloth underneath there is still hot. So what I would do is, after I poured it, it would be up here. I would just leave it up there. So it's up in the air. It's away from everything hot. The crucible's down here on the floor after we're done pouring. Just leave it there. Okay? And then when we're done, we're going to go over here and turn, make sure that's all right. We're just going to put the main power off and then turn the pump off. Okay? Don't turn that pump off unless you can literally put your hand. I do this. I put my hand on the inside of that refractory, make sure I can touch it. Of course, you do the whole thing. Put your hand near it. Yeah, and kind of touch the back. Okay. Fine. You put your hand on it. It's cold. Turn it off. Okay. So that's generally the procedure of on and off on that furnace. Just be careful. Okay, one other thing, safety-wise. How do I add material? Let's say I got not enough metal. I want to add some more. And I thought about it too late. So as this thing is melting, we're charging more material. Remember, making sure not to jam it going in there, right? Because it'll expand. But if I want to add another piece in there, it's just like pouring molten metal into something rusty. It's got moisture on the surface. You don't think it does, but it does. Okay, so how do I get that moisture off? I got to get like 200 or 300 degrees. Okay, so how do we do that? I typically just lay it here on the surface. And there is a little bit of a magnetic field that comes up here, but it's not instantaneous. So if you put it up there for like 30 seconds and then put it in and just throw it in there, you're going to have problems. When you don't have any molten metal on the ceiling here, when you go to an aluminum foundry, you look over the furnace, if they have a furnace like this, and you look up at the ceiling, and you'll probably see little drips of aluminum up there because someone goofed up. And sometimes people try to play jokes on each other, and they throw a little bit of water or something stupid in there, and it usually ends poorly. If you look that up on the internet, you'll see some pretty horrific stuff on how people got burned and that kind of thing. I am going to put another safety video up onto the site when I find it about furnace safety and that kind of stuff. This is 480 volts, 200 amps, something like that. Okay? It will kill you dead, like the first time. You don't get a second chance. If you get in this cabinet, you touch one of these capacitors, they're 1 farad capacitors, it will kill you dead. Okay? It'll blow you across the room. So anything electrical, don't mess with it. I'll take care of it. Be careful of stuff like, you see these little things right here? If for some reason this furnace was on, and look at this. There's some aluminum that made it from out of the furnace to over here. It made a burn mark, so that's not good. Not sure what's going on there. So yeah, if you were to hold on to those, turn that furnace on and give it the juice, you would get fried. Okay? So we should probably cover those up a little bit. Those are all covered there. I don't know. Any questions on anything, guys? Okay. I think it's probably time we can switch around.